Hey everybody, for those of you who are here already, if you can hear me, just go ahead and say so in the live chat. Great, thanks. Alright, well, I'm just going to jump right in then. So we're going to be starting from week 10 and aiming to get all the way through week 13. This session, I'm probably not going to have to do quite as much explaining, and a lot more of it is going to be focused on project-based demonstrations. So you're going to see me work through a number of the projects in addition to walking through the in-class quizzes, exercises, and all that jazz. So week 10. How do you target specific index of an array? Well, if I have an array called my array, and it has the numbers 1, 2, 3, 4, 5 in it, I target a specific index by writing my array, the name of the array, and then in square brackets, the index which I want to access. In fact, let me go ahead and change these to strings, so as not to confuse anybody. Okay. So we have the name of the array followed by the index of the item we want to access in square brackets. What we should see in my console when I load this page is not 1, not 2, not 3, but 4, because this is the 0 index, 1 index, 2 index, 3 index. That is an important distinction. And just to as a reminder for everybody how array and indices work, we're going to compare my array.length and here we go. We have 4 being logged to the console because 4 is the third index in this array, but this array happens to have 5 items inside of it, so it has a length of 5. And that's important. Don't ever confuse indexes with length. Okay? The last index in this list is actually 4, and yet this has 5 items. This is the 5th item, but it is sitting at the 4th index. Okay, and something, one very common pattern in JavaScript that you'll see yourself and other developers using quite a bit is dynamically targeting the last item in an array. If you don't know how long an array is, if you don't know the index of the final object, final item in an array, there is a surefire method using JavaScript logic that will allow you to access it regardless. And that method looks like this. It's the name of the array followed by the index, and that index in this case is going to be the length of the array minus 1. And it returns the last item in the array, no matter what. And this is because, think about it, think about the relationship between the length of an array and the index of the final item in that array. Index 0, 1, 2, 3, 4. But what is the length of this array? 1, 2, 3, 4, 5 things. So 5 minus 1 returns 4. And what is at the 4th index of my array? It's 5, the very last item in the array. No matter how many items are in my array, this line of code is always going to return the last item in the array. So if you do not know or have not internalized this particular pattern, do so now. This is very useful. All right, moving on. How would you reverse the order of an array? Well, that's pretty simple. Let me make my text bigger. Sorry, folks. How would you reverse the order of an array? Well, myArray.reverse 5, 4, 3, 2, 1. dot reverse function. How would you log the length of each item in an array? Well, this is a little bit more complicated. So how do we get the length of an array? We have the name of the array followed by dot length. So we select the length property of this array. Every array has a length property. Even if there's nothing in the array, the length is 0. Every array has a length property. So my array, the title of the array dot length, will return the length of the array, or the number of items in the array. But what we want here is the length of each item in the array. So just to show you what I mean, let's say I have a variable called myString, and it just says hello. Well, strings also have a length property, so I can access myString.length and return also 5. 1, 2, 3, 4, 5 characters. If my string just said hi, then my string.length should be 2, and that's what we get. So we want to access the length of every individual item in this array, which means we're going to examine and try to access something belonging to every individual item in this array, which should, to your minds, scream for loop. So we're going to write a for loop for I equals 0, I is less than my array dot length I plus plus. And for each item that we loop through, as we loop through this entire array, we're going to console.log my array at the given index, depending on which loop we're running, dot length. Okay, this is not going to return the length of the array. This is going to return the length of whatever is at the I index of my array. So when I equals 0, my array at the I index is going to return 1. So what's the length of 1? It's going to be 3. 2, also 3. 3, 1, 2, 3, 4, 5, it's 5, etc., etc. Okay, my array at the I index dot length. Let's reload, and there we get 3, 3, 5, 4, 4, which is about right. And if I want to make sure that we don't have any duplicates, 3, 4, 5, 4, 5. Let's do that. There we go. 3, 4, 5, 4, 5. So I just added those underscores so that we didn't get the console was not stacking any of these numbers. That's what it does when you return multiple console lines. If one value is the same as the other, you'll just see that little 2 populate next to it. Just like this. So don't let this confuse you. This just means it returned 3, and then it returned 3 again. This returned 4, and then it returned 4 again. Okay, and this for loop, the length property of whatever is at the I index of my array is how we return the length of each item in an array. All right, exercises. Create an array with 5 different strings. My array equals, let's go Evan, Adam, Lisa, Nick, Matt. 5 different strings. Log the length of your array to the console. Console.log my array dot length. Now log the length of each of the strings in your array to the console. Well, we just did that, so let's go ahead and do it again. For I equals 0, I is less than my array dot length I plus plus. Just a reminder, if anybody is still confused about how for loops work, we start with I at a base value of 0. As long as I is less than my array dot length, we will run this loop. And whenever we finish one loop, we're going to add 1 to I. That's how these 3 arguments work. As long as this middle one returns true, we're going to run the loop. Whenever we finish running a loop, we add 1 to I. And our starting value for I is going to be 0. All right. And inside this loop, we're going to console.log my array at the I index dot length. Let's see if it works. Okay, so first we get the length of the array, which is 5, and then we look at that, they're all 4 letters. And then we get the length of each item in the array, all of which happen to contain 4 characters, which is an unfortunate coincidence. Okay, finally, reverse the array and console the array again. So to do this, there's 2 ways we can do this. I could do my array dot reverse and then console.log my array. Then we get Matt, Nick, Lisa, Adam, Evan. So the array has been reversed. But we could also very, very easily save ourselves a line of code here, and it's something that you might want to start considering now that you're getting deeper into JavaScript. You want to start writing more efficient code. Okay, so here we're just going to console.log the reverse of my array. And get the same exact thing in the console. And my array has still been reversed. Okay, nothing has changed except we have saved ourselves a little bit of code. Okay, create an array of at least 5 numbers. Our numArray equals 546, 92, 178, 401, and 3. Sort the array numerically in ascending order, then sort it in descending order. All right, so this is a little complicated. There's no extremely easy way to do this using JavaScript. Or rather, it is easy, but it's not obvious. Okay, you have probably learned by now that there is the sort function, which you can apply to arrays. So let's go ahead and give that a try. I'm going to try console.logging numArray.sort, and let's see what we get. We get 178, 3, 401, 546, 92, which is not sorted in numerical order, right? What it is, and what .sort is actually doing in this case, is it is actually sorting them in numerical order according to the first digit of each of these numbers. 1, 3, 4, 5, 9. That is useless to us, as I'm sure you figured. Now, .sort is much more useful in sorting things alphabetically, A, E, L, M, N. And it's essentially trying to do the same thing to numArray. It's trying to sort all the numbers by the value of that very first digit. But that's not what we want to do. That's not particularly useful to us. It's not meaningful for what we're going for here. So what we need to do is inside of .sort, we're going to feed in a function. And this function is going to take 2 arguments, A and B. And what this function is going to return is A minus B. Let me separate all of this so nobody is confused. And I'm going to also comment and label everything. This is the console log. This is the closing console log parentheses. This is sort, closing sort parentheses, and this is our function. And these are this is our closing function curly brace. And this return is what our function returns. Okay, so let's break down what's happening here. First, we're going to start from the very inside and work outwards. Okay, that's how you should always approach breaking down nested hierarchies like this. Return a minus b. So this is what is being returned, and it's being returned by this function, which takes an argument a and an argument b. Remember, a and b are essentially placeholders. Whatever a and b are in a given scenario, they get plugged into this equation here, and that's what is returned. Okay, so this function is returning whatever a minus b is, given a and b as arguments. And whatever is returned is then processed as the argument of this dot sort function. Whatever gets returned by this function gets plugged into dot sort. Okay, and that is what's actually contributing to how NumArray is getting sorted. First of all, we can prove that this is actually going to work for us. 392, 178, 401, 546. So it is being sorted numerically. What function AB is doing is it is taking one number A and one number B, and it is testing which is larger. Okay, the way this basically works is if the value returned by A minus B is positive, well then obviously A is a greater number than B. If it's negative, then obviously A is a lesser number than B. And every possibility, every pair, every combination of two numbers is plugged into this function until essentially all of them have been tested against all the other numbers in this array, and we have determined the relationships, which number is bigger than all other numbers, which number is bigger than all other numbers but 1, which number is bigger than all other numbers but 2, etc., all the way down to the smallest number in the array. Okay, so that is how we sort an array numerically. Function AB, return A minus B inside of a dot sort function. If we want to sort it in decreasing order from greatest to smallest, then we simply need to switch A and B. If we return B minus A, then it will reverse the sorting of the array. Okay, so this function inside of a sort is what actually numerically sorts an array of numbers. It's a good thing to know. Okay. Create an array with 3 strings. For string array equals okay, we have an array of 3 strings. Add 2 new strings to the end of the array. Now remove 1 string from the beginning. Log the final array to the console. How many strings does it have? So first, let's go ahead and just console log the array so we know what we're starting with. And then we want to push 2 new strings to the end of the array. We do that with the push function. String array dot push, and then new string 1, and new string 2. And now what we will do is console log string array again. Okay, so here we have the original array, and here we have the new array. It's gone from containing 3 items to containing 5 items. Dot push. That adds items to the end of the array. Now remove 1 string from the beginning. So string array dot shift console.log string array. Okay, so we go from 3 items to 5 items to 4 items. And look, the first item now is goodbye. It's not hello world. Dot shift removes the very first item in an array. How many strings does it have? 4. We've answered that already. Now, when you use something like .shift or some of the alternatives, there's unshift, there's pop, there's a couple of different array functions. You don't have to, well, let me go ahead and just clear all this out. We'll do this in the console. String array is still here. Okay, it still exists. It only has 3 items now. If I actually run string array.shift, do you think it's going to return the new array, or is it going to return the item that gets pulled out of the array? Well, the answer is it returns the item that gets removed from the array. String array has now been changed. It only has 2 items, but string array.shift as a function actually returns the item which has been removed from an array. This is important. All functions, all methods, they all return something. They don't just do something necessarily. They all return something, and you need to be aware of what is being returned in any given scenario because it's really easy to break your code and not realize you're breaking your code because you're not fully aware of what kind of data type a function is returning, or what particular data type a function is returning. And it's often difficult to troubleshoot issues like that. So it's important to be aware. If you're not sure, again, just jump into your console and test it. I mean, if I do string array.push new string, I don't know why I'm camel casing, it's a string. New string, what do you think it's going to return? Is it going to return the new string, or is it going to return the array plus the new string? It returns neither. It returns the number of items that the array now contains. We've gone from 2 items to 3 items. Okay, that's another unexpected outcome, or potentially unexpected. If you expected it, then bully for you. But this is important because you may be using arrays together in multiple ways or manipulating arrays, and at some point you may dynamically require the number that represents how many items an array contains after you push something. Well, you might, not understanding what this as a function returns, write .push, push a new string, and then string array.length after that, when you don't have to. You don't have to. You could actually just store it in a variable. Let's go var new length equals string array.push another new string. Okay, now new length should be 4. It is. And string array now contains another new string in addition to all the others. So we both changed the array and returned a potentially useful number representative of the length of that array all at once. Okay? This is what I'm talking about, making your code efficient, more efficient, but more importantly, it's about understanding exactly what is happening. Understand exactly what is being returned. So once again, we can also store removed items. Removed item. String array dot shift. Now, string array should be missing its first item, which it is, and removed item, the variable, should contain the missing item, or the removed item. Also important. Something you will frequently do in manipulating arrays is something like this. You'll often have, let's just call it removed items. We'll have an empty array here. And if we want to preserve all the data contained in string array, but for whatever reason we want to move them or remove them from string array, then what we are probably going to do is, rather than just do string array.shift, and rather than store string array.shift in its own variable, we're going to do removed items dot push string array.shift. And what that's going to do is it's going to remove the first item from string array, and it's going to automatically add it to removed items. So in case we ever need to access any of that data, which we removed from a given array, it's now stored in this extra array that we can access whenever we want. Now this is a really simple example. These are just 3 strings. But what if each of these items that we're moving is an object? What if it was a zodiac? What if it was a student with all of their data? Name, age, test score, I don't know, outstanding tuition, whatever. However complex of a data you want, all of these strings could represent a very, very complex object. So you don't usually just want to remove it and toss it in the trash. And this is an example of manipulating 2 arrays at the same time in a meaningful way. Okay. So once again, dot shift pulls an item from an array and returns that item. Dot push adds an item to an array and returns the length of that array. You can explore the other array functions like unshift and pop on your own, now that you know how, hopefully. All right, moving on. The project for week 10 is the quiz. Before I dive into the quiz, I did the comment app last week. I haven't actually gone over the zodiac, I don't believe, and I think that's going to be pretty useful here. So I'm going to be really quick about it. I'm not going to spend a whole lot of time on this, but I did promise I would code the zodiac, so that's what I'm going to do. I'm going to start in my HTML and get myself set up. Enter zodiac sign below. We have our input, type equals text. I'll give my input NID, user input. Then we have button, type equals button. On click equals get horoscope. And below all of this, we're going to have an empty h1. This is something that we do with the zodiac. There are obviously many ways to build this particular application, but this is how we approach building it at week 8 in the course, which is the week for which this is a project. So this is, you can think of this as the easy way to do the zodiac app. I'll expand on it a little bit once we're done. Alright, so I've created 3 empty HTML elements, an empty h1, an empty paragraph, and an empty image. They have no content, so we should not see anything here. Let's load our page, make sure it looks the way we want. Great, grand, looks fantastic. Okay, now we jump into our JavaScript and we need to set ourselves up. The first thing that we do, ideally by this point you've planned it or you've at least looked at the Codify examples, but you set up your data. Okay, so we need an array of our actual zodiac signs. I'm only going to do 3 signs just for the sake of brevity here. But the principle is the same whether you have 3 or 12. Sign Aquarius. Fortune. You're great. Okay, so here's me using an apostrophe inside of single quotes. How would I fix this? You would either need to use double quotes here instead, which is dumb. You would either need to change these quotes on the outside to double quotes, which works, but if I want to keep single quotes, keep it consistent, then what I would need to do is escape that character with a backslash, which tells the browser this is to be read as text. And in addition to fortune, we need an image. Do I have any images in here? I do, I have 4. Perfect. Okay, so inside of the image property of this object, I'm going to put in the image file path. The image file path as it would appear if it were written in HTML. The reason I write it that way is because we're injecting this into our HTML. Okay? We're not navigating to our image folder from our JavaScript page. If we did that, we would need the ... but we don't, because this is going to be injected into our HTML. And it is important that you are comfortable with relative file paths. If what I just said does not make sense to you, we need to talk about relative file paths, and we definitely should as soon as possible. Reach out. So, Aquarius, Libra, and I don't know, Scorpio. Okay, and these images are completely random, so they are obviously not appropriate for the actual Zodiac app, but you can apply the principles here to any kind of application you'd like. It does not have to be about Zodiacs. It can be an application where, what superhero are you? All right, we've set up our Zodiac array. Now we need our other variables, which we're going to use as shorthand to target our HTML elements. So var empty h1, var empty p, and var empty image. And I'm going to use query selector here rather than get element by ID. If I were to use get element by ID, please note document.get element by ID. You do not include the hashtag in get element by ID, just like you do not include the dot in get elements by class name. However, if you use query selector, which returns one element, the first element of its kind that it finds, query selector accepts CSS selectors. So query selector, I do use the hashtag, or the dot, or the full compound CSS selector, or the full also compound CSS selector, whatever it is, in query selector or its counterpart query selector all, which returns a collection of elements. You do in fact use the full CSS selector. Document.getElementById only takes the name of the ID. If you put a hashtag in there, then it's going to look for an element that has this ID, which is not how we write our IDs. Okay, just an important thing to note. I'm using query selector because it is a more advanced selector for JavaScript. I'm not going to explain it. You can figure it out on your own, I'm sure. But for variety's sake, we've got query selector and get element by ID here to select all of our empty elements, which we're going to use as our shorthand. Okay. Those are our variables. Let's also make one for our input. var input equals document dot, let's do get element by ID again. Actually, no, get element by tag name, for variety's sake again, input the 0 index. Okay, and if you're not sure what this is going to select, you have to say so in the chat. I'm not going to explain it unless somebody asks. Okay, and this should be get elements, pardon me. Do we need any other variables? We've got our input, our button has an on-click function, and we've got our empty HTML elements. I think we're good to go. So now we're going to set up our get horoscope function. And what do we want to do in this function? The first thing we want to do is check if whatever a user types in here matches one of our zodiac signs. So what are we going to do? If input, which is that first input element on our HTML page, dot value equals equals. And then we need to check it against each sign in each of our objects in our zodiac array. So this needs to be inside a for loop. Let's just set that up real fast. Like 0, I is less than zodiacs.length, I plus plus. Okay, so if input.value equals zodiacs at the I index dot sign, okay, just like we were using dot length in the very first example of today. If input.value equals zodiacs I dot sign, that means we have found a match. And if that happens, what we want to do is take empty h1 and set its inner text equal to zodiacs I dot sign. And we want to take empty paragraph and set its inner text equal to single equal to zodiacs I dot fortune. And we want to take empty image, and we don't want to use inner text here, right? An image doesn't have inner text. Inner text is not going to do anything. So what's the property or attribute that we need to inject this image file path into? It's an image source. So empty image dot source equals zodiacs I dot image. The alternative way to do this last one, I'm going to show it because I did say yesterday that set attribute, no, not yesterday, last time, that set attribute is my preferred way for changing element attributes. You would use the set attribute function, and we're going to set the source equal to zodiacs I dot image. This does the exact same thing. I do still recommend using set attribute because becoming fluent with set attribute is going to be more valuable to you than knowing that you can just use dot notation to access the source, because sometimes this won't work, or sometimes you'll need to do more than this, or sometimes, especially if you're changing an element style attribute, set attribute is a more efficient means of coding. It will save you potentially several lines of code. Also, I just like it more, so there. Deal with it. Okay, and once we do that, our function is complete. Let's reload my page. I'm going to type in Aquarius and hit my button. Oh, misspelled my array name. And it works. We get the name of or the sign of our fortune, of our horoscope. We get the image assigned to that horoscope, and we have our fortune down here. It's very small. You might not be able to see it. But it's all there. It all automatically populated in our HTML. And we could try the others as well. Libra and Scorpio. Okay, so that is how the Zodiac app works. What you may need to think about: one, you need to be sure that you're using dot value to refer to the text content of your input. Remember, that is how you target, how you select, how you manipulate the text contained inside of an input. It's distinct from placeholder. An input doesn't have inner text or inner HTML. It's just dot value or value. Other things is, if I actually type in Libra with a capital L, it's not going to work. Okay, and that's not right. We want a user to be able to type in Libra with a capital L, and it should still work. So in order to do that, we come in here where we're testing input.value, and we want to automatically convert it to lowercase. So no matter what a user types in, it's going to be converted to lowercase, and that is what's going to be checked against zodiacs I.sign. So let's just check and see what that means in our console. If I type in Libra with a capital L into my input, and in my console I write input.value I get Libra with a capital L. If I write input.value.to lowercase, I get Libra with a lowercase l. And that will successfully match against the sign property of the second object in my zodiac's array. Okay, so that's number 2. You got to make sure that your input is not case sensitive. You don't want it to be case sensitive. Number 3 is when this didn't work. Let me show you again. If I type in elephant, which is obviously not a zodiac, nothing happens. So if I was a brand new user who didn't know what zodiacs were, I wouldn't know if the app was just broken, if it was just taking a long time to load, if something else is supposed to happen. And you need to be aware of the user experience here. A user needs to know that what they typed in is not going to work. They don't necessarily need to know why. That's up to you. But they need to know, they need some kind of visual feedback that tells them, oh, the app isn't broken. I did something wrong. I typed in something that is not going to work. So what most students tend to think of when they encounter this problem is, let's add an else statement after our if. So if it doesn't match, we're going to have an alert. That's not a valid zodiac. Okay, and that's a perfectly valid alert statement, but look at where the else statement is. It's still contained inside of our for loop. And think about how the logic of this whole thing works. Okay, if a user types in Scorpio, then when I is 0, does Scorpio equal zodiac 0 dot sign? Does Scorpio equal Aquarius? No. So we're going to jump to the else statement, and they're going to get an alert. That's not a valid zodiac. Then we're going to keep running the loop. When I equals 1, does Scorpio equal Libra? No. So it's going to jump to the else statement, and they're going to get an alert. That's not a valid zodiac. You're going to hit OK, and then the loop's going to run again. Does Scorpio equal Scorpio? Yes. We run all of this code, and then we're done. But that's not what we want. We don't want a user to receive this alert for as many times as there are zodiacs with which they did not match. Okay, we only want this alert to show up once, and only in the event that they write something that does not match any of the zodiacs. Okay, so what we want here is not an explicit else statement, but really implicit else logic. Okay, so I'm going to cut this alert and get rid of my entire else statement. And what we're going to do instead is, if we find a match, we're going to do all this stuff that populates the HTML, and then we're going to return, which means the function, the whole getHoroscope function, is going to end. So if we find a match, we populate the HTML and we break out of the function. Okay? Otherwise, if we run through every single zodiac we have, our entire for loop, and still find nothing, no match, then we're going to have an alert. Okay? We run through the entire for loop, and only if we don't find any match at all do we run an alert that says that's not a valid zodiac. So now let's try it. That's not a valid zodiac. And I only get it the once. I don't remember if I actually showed you what it would have looked like before. So here's with the explicit else statement. I'm going to type in elephant. I'm going to hit click me. That's not a valid zodiac. I hit OK. That's not a valid zodiac. I hit OK. That's not a valid zodiac. I hit OK. So once again, this is the logic you want to exercise for your Zodiac app. Obviously, there are ways to make this more compelling, a much more interesting app, and if we have time, I'll come back to it, but this is all I want to talk about, the minimum of what I want to speak about with regards to the Zodiac app at this time. After we get through the other projects, I may come back and we can talk about how to make this much more interesting. Okay, so that is week 10. Then we have the quiz. quiz example. All right, let's do it. There are a lot of different ways to do the quiz. Okay, there's the easy way, where you write your questions and your inputs. You know, this is a question, and you have your inputs, which have some kind of ID. This is answer 1, and maybe you even give your inputs a like a name property that actually contains this is the correct answer. And then in your JavaScript, you're basically going to grab the element with the ID of answer 1 and check, does its value equal its name? Well, that'll work. You could do that, but that's the easy, very boring way to do the quiz. Okay, I'm going to show you a more interesting way that relies almost entirely on JavaScript. Actually, yeah, it's going to rely entirely on JavaScript. No HTML, no CSS. Pure JavaScript, okay? 1 second. Okay. All right, so first we got to think of our questions and answers. And I'm going to store these in a Q&A array. And each question and each answer is going to be represented by an object, a JavaScript object with a question and an answer property. So let's keep it simple. What is the main character's, gotta escape that character's name in the Iron Giant? Answer, Hogarth Hughes. Don't forget your commas between your properties, your commas between your objects. I'm going to do 3 questions. Who plays the voice of the Iron Giant? Vin Diesel, for some reason. Who directed the Iron Giant? Brad Bird. Okay, those are our 3 questions and our 3 answers. Now, given that we're using entirely JavaScript, we're going to try to dynamically generate these as HTML elements and content so that we can actually see them. Okay, so first thing that we're going to do is write a for loop. For var I equals 0, I is less than Q and A dot length I plus plus. So for every item in Q and A dot length, we're going to var new div equals document dot create element div. We're going to create a new div. Okay, sorry, getting Slack messages. Document dot create element div, and inside that div, well, we're also going to create a label equals document dot create element label, and new input equals document dot create element input. So the input is going to be for our answers, the label is going to be for our questions, the div is going to contain them both. So new div dot append child, new label, new div dot append child, new input. I think we could actually streamline this quite a bit more, but I'll come back to that. It's not necessary right now. Okay, and now we want to put some content into these labels and inputs. So new label dot inner text equals Q and A at the I index dot question. Okay, so it's going to take the question property of the given object in the Q&A array and insert it as the inner text of the label. Okay, And then after our for loop, we want to create some kind of submit button. So not inside our for loop, but after our for loop. I'm going to do var button equals document.create element button. And we want this button to have an onClick function that runs a function which checks our answers, right? Well, how do we add an onClick attribute from JavaScript? We could use an event listener, which is something we'll talk about in a little bit, but easy way, which we've already learned, is button.setAttribute onClick. And the value of it is going to be check answers as a function. We haven't defined this function yet, we will. But now our button has an onClick attribute equal to check answers. And it also needs some text, or it's just going to be an empty button. So button.innerText equals check answers. So now we should have a correctly populated quiz if I had appended anything to the body. So I missed that last step. Do as I teach, not as I do. New label that intersects with a question. So after we create the label and input and put them inside the div, we actually want to append them to the body. Or if you'd like, you can append them to any element inside your body as long as you target it correctly. I'm going to keep it simple for now. And we also want to append our button. Okay, there we go. We've got 3 questions. Let me make it bigger. 3 questions, 3 input fields, and a button. And I'm going to put these inputs inside a div too, okay? So that they sit inside a block element. Okay. So I append new div 2 to new div, and I append new label to new div, and I append new input to new div 2. Let's switch the order of these so the label is first. There we go. Okay, easy, straightforward. 3 questions, 3 input fields, and a button to check answers. Well, we need to define that function now. So function check answers. And what we're going to be doing is we're checking all the answers at the same time, right? We're not checking them one at a time. We're not checking them as they're typed in. We're checking all the answers all at once. So that requires a for loop. For I equals 0, I is less than what? Well, we have as many input fields as we have objects in Q&A, so we can still use that. We always will have as many input fields as we have objects in Q&A because we've hard-coded that logic. Q&A.length I++, and inside our for loop, we're going to check the value of each input against the answer property of each object in Q&A. So here's where we need a little creativity. Inside of our function, but before our for loop, I'm going to create a variable called inputs. And this is going to be document dot, we could do get elements by tag name input. This is going to return an HTML collection of all the inputs in our HTML, which should be 3. As we said, we're going to have as many inputs as we have Q&A as we have objects in Q&A, so I could also do inputs.length for this for loop. Get elements by tag name input will return a collection, an array-like collection of all inputs in our HTML. For variety's sake, I'm going to use query selector all, which will return the exact same thing. Okay. And now that we have that, we're going to finish the for loop. We're going to compare inputs at the given index I dot value, and we're going to compare it against Q and A at the given index I. Even though Q and A is not referenced here or anywhere else in the function, we're still referencing it here. We know that the first object in Q and A is going to correspond to the first input in our HTML by virtue of this for loop where we create all of our elements. So this logic will work, and we're comparing it against the answer property. It should be in an if statement. And just to make things a little more forgiving on our users, I'm going to do 2 lowercase again, so it's not case sensitive, which means I also need to make all my answers lowercase, so it's not case sensitive. Although, considering that it's asking for names, it could be. But maybe not all of your questions are asking for proper nouns. Okay, so that's our if. Inside of our for loop, we're checking this for every item in Q&A, every object. And if it does match, well, what do we want to do? That's the next question. We need to give the user some feedback, some visual feedback that tells them that they got this question correct or this question incorrect. So let's do this with some styling. I'm going to take if in. Wow, that is bizarre. Sorry, folks. Easily distracted. If inputs I.value.to lowercase equals Q&A I.answer, then inputs I dot set attribute style, and let's give it a border. Border 3 pixels solid green. Okay, so it's going to give the input field a green border if it's answered correctly. And let's also do an else. If it's answered incorrectly, we're going to do the same thing, except it's going to be a red border. Okay, now let's try it. I'm going to reload my page. What is the main character's name? Hogarth Hughes. Me and Brad Bird. And there we go. Correct, incorrect, correct. So this is a dynamically generated quiz app. No CSS, no HTML, and all we need to do, we could add as many questions to this array and answers as we want, and it will automatically and correctly create question and answer fields for all of them. And then obviously if you want, you could style it to make it not look like crap. But here we go, a dynamically generated quiz app. Dynamic generation like this is always great because you know what you could do with this? You could make an admin form where anybody who's administering this quiz could actually log in and create new questions to add to it. And it will work. All the functionality is already coded in here so that if someone had a form on the side where they could type in a new question and the correct answer to that question, it will get automatically added to that quiz for any future test takers or any future students. And you can do this with a lot of the projects we're going to go over today. You can do something like that for the e-commerce project. You can do something like that for any of your API projects. I don't think we're going to get that far though. Okay, so that's the quiz app, and that's a nice, comfortably complex version of the quiz app made entirely with JavaScript that you can definitely boast about if you do it yourself. I hope that was helpful, and let's move on to week 11. Week 11 has no discussion questions, if I remember correctly. And we're into object constructor notation. Okay. Object constructors are a difficult thing to explain or to show off, but I'm going to do my best. Object constructors allow you to streamline a lot of your JavaScript by creating objects on the fly. They're factory functions. They create objects, and you can determine what properties those objects are going to have ahead of time. So think of an object constructor function as a blueprint that you feed into a factory that tells it what everything it produces, the specs for everything it's going to produce from here on out. So the next time you need to create an object with a certain set of properties, you can make as many of them on the fly with much less code than you would otherwise. So what we've been dealing with up to now are called object literals, and they look like this. They look like this. This is an object literal, okay? What we're dealing with now is object constructor notation. And the way this is going to look is we write a function followed by the name of our object. Let's just go for person for now. And we're going to feed into this a name, gender, name, age, do hair color, and job. Okay, 4 parameters, 4 arguments are being fed into this function when it is called, and the name of this function is person. And inside constructor functions, you'll frequently see stuff like this. This.name equals name, this.age equals age, this dot hair color equals hair color, and this dot job equals job. And this really confused me in the beginning. It really did, because I wasn't sure which of these names is referring to this name. Which of these names is the argument that has been fed into the function? And the answer is it's this one on the right. This one on the right. And to demonstrate, we can actually change the names of these functions to completely random variable names. They don't have to be indicative of what the properties are actually going to be. What this is saying is that we have received 4 arguments into this function, and the object that this function is going to produce is this. It's going to have a name property equal to the W argument, and it's going to have an age property equal to the X argument, and it's going to have a hair color property equal to the Y argument, etc. So if I ran var me equals new person. Oh, another thing is what usually when you see constructor functions, they are actually capitalized. It's not strictly necessary, but it's very common syntax, and it usually indicates a constructor function, so it's good to know. New person, and the first one is going to be name, so Evan, age 8, hair color brown, and job I still don't know. Yeah, gotta escape that character. Okay. And what this is going to do, we can now call this in my page. Reload. I'm going to call me, the variable me. And what it contains is an object. It contains an object with a name property. I mean, it looks like this in object literal notation. Name Evan, age 8, hair color brown, job I don't know. I still don't know. Okay, this is exactly what the object which is produced by this function looks like. And this is now what is stored in the me variable. Okay, I hope that makes sense. We run a constructor function with the word new. That's very important. New, followed by the name of the function with all of the necessary arguments that it's going to be looking for. So if this only took 3 arguments, then we would need to only insert 3 arguments. And then the object would only have 3 properties. That, in a nutshell, in and of itself, is a constructor function. And to understand constructor functions, that's all you really need. That's all it is. That's all it does. It creates objects on the fly. So if you have 100 objects, rather than have to write object literal notation 100 times, you would write one constructor function, and you would just write new, whatever your object name is, with the correct arguments 100 times. It still seems like a lot of code, though. And this is what confuses students a lot. Like, what is the benefit? What is the real appreciable benefit of constructor functions? Well, think about it. Think about how you might use it. Okay. It doesn't seem like it would save a whole lot of time to do this rather than just write an object literal. I get that. I totally do. And I had the same trouble appreciating what constructor functions are for when I first learned them. But let's say we want to make our constructor function have more contextual purpose. Rather than person, let's pretend this is a store, and it's going to be a shoe store. Okay, we're going to have name, color, and size, and price. Let's do price too. Okay. And what we are is a shoe store owner with an online e-commerce store. Okay. Well, we don't really want to do a new variable for every type of shoe that we have in stock. But we may have to, at least the first time. The way we probably store our inventory data, though, is with something like an array inventory. We're going to keep it empty for now. We're going to populate it dynamically using this constructor function. Well, if we receive 4 different kinds of shoes, we have 4 different kinds of shoes, and we want to populate our inventory array, then we would write inventory dot push. We could do new shoe. What's the name going to be? It's boot. I'm not very creative today. So boot, it's black, it's large, and it's $50. It's one new shoe. And then we have a sandal. It's brown. It's extra large, and it's $20. And we have the unfortunate bandle, which is tan, and it is small, and nobody wants it, so it's $10. 1, 2, 3. And then we have the sneaker. And so I promise this will get, we are going to condense a lot of this code that we're writing right now. I'm just trying to get us set up. And it's $25. Okay, so this is going to create a new object using our constructor function for each one of these shoes and push that object into inventory. So if I reload my page and I call inventory, I now have 4 shoe objects, each of which has 4 properties. Okay? So that part's taken care of. We've effectively populated our inventory array. We will come back to that. Now we got to do something with all of that information in our inventory. So let's go ahead and write a for loop. Okay, this is going to loop through everything in our inventory, every object. And let's keep it relatively simple for now. I'm going to create new div, document.create element div, and I'm going to set the new div dot inner HTML equal to inside this div. How am I going to do this? We've got, I'm going to create an h1 plus name. Sorry. h1 plus inventory I dot name plus closing h1 tag plus, let me move this on the last line. Okay. Closing h1 tag plus, what's next? The color. Let's do an opening h5 tag plus inventory I dot color plus closing h5 tag plus, and we have size, just do another h5 plus inventory index dot size plus, and then we'll do a paragraph for price. And let's also do a buy now button after the price. Button type equals button and then document.body.append child new div. Okay, so this is all inside of our for loop, which means we create a new div, we set its inner HTML equal to an h1 with the inventory name, h5 with the color, h5 with the size, p with the price, and a button. And then we add it to the body. Then we move to the next item in our inventory. And what's happening is we get every piece of inventory listed on our e-commerce site. Okay? Still doesn't really seem like the constructor function saved us a whole lot of time though, right? And that's kind of true. As a consumer, as a buyer, it didn't save us a lot of time. Real quick, before we keep going, I know what I'm gonna do. I'm gonna set myself up for some easy Bootstrap styles because I can't look at this any longer. Div class equals container. And I'm going to add all of my projects, all of my products, I mean, inside a row with the ID of products. Okay, so I'm going to append them all to this row rather than to the body. Document dot query selector row. And in order to make these Bootstrap styles a little more meaningful, new div dot class name equals column for text center. Yeah, that'll do. once I broke it. Oh, it's not class. It's ID of products. There we go. All right, a little better. A little better. Give them a margin top. Okay, there we go. We've got 4 products. It still doesn't seem like this constructor function has saved us a whole lot of time, and that's true. I mean, arguably, if you had 100 different shoes, this is easier than writing a bunch of different objects inside this inventory array, but it still doesn't feel like it's that much more helpful. Yeah. So I'm going to go ahead and comment out all these functions that we already ran. And I'm going to include this for loop inside a function called populate.html. So now the for loop isn't going to automatically run when we load our page. It's inside this populate.html function. And every time this populate.html function is run, it does this, where it creates a div with all of this information based on all of the items contained in the inventory array. And let's also pretend that being the admin of this store, we have an admin access to the store page. So I'm going to create at the very top form. And this form is going to have 4 inputs where I can add new products. 1, 2, 3, 4. Just to make things easy, let's give them IDs. Name, color, size, and price, and an actual submit button. New shoe button. Okay. Now in our JavaScript, let's go ahead and this doesn't need an ID. I'm going to give it an onClick function. It's called new shoe. Not to be confused with our constructor function, which makes a new shoe. Function, new shoe. What are we going to do here? We're going to take var name equals document dot query selector name dot value. I'm going to do the same for the rest of those inputs. Color equals query selector color dot value. Size equals query selector size dot value. And price equals query selector price dot value. Once we have all those variables set up, we're going to run inventory.push new shoe. The arguments are going to be name, color, size, and price. And once we do that, we're going to run populate HTML. Okay. So here's our unfortunately formatted form at the top. And let's add a boot. Color is going to be black. Size is going to be medium. And price is going to be $45. Submit new shoe. And it creates an inventory card for me. Now here's a problem. Every time I hit submit new shoe, it's now multiplying by way more than I want. I just want to add 1 new shoe each time. And the reason that's happening is because our populate HTML function is appending all of what is currently contained inside of products to itself. So it's more than doubling every single time. So the way we want to fix that is inside populate HTML, before we append to our products div, we're going to select our products div, and start by setting its inner HTML equal to nothing. And then what we're going to do, actually that's all we got to do. That will take care of it. So let's try this again. Boot, black, medium, 45 bucks. 1, 2. I've confused myself. So let's see, what are we doing? We create a new div. So the new div.className equals okay. I'm going to go about this an entirely different way. I'm going to set new div equal to just a gigantic string. It's going to be div tag plus each one, all that jazz, and at the very end we're going to close our div tag. And when we run new shoe, we should push the new shoe to inventory. Changing it, which is not what we want. Okay. So new div is all of this. We're going to set products HTML. Okay, no, I'm sorry. I am overthinking this. I see exactly where I messed myself up. So this part where we reset the inner HTML of products, I put in the wrong place. It's going to go inside our populate HTML function, but outside of our for loop. Okay, so first we reset the inner HTML, then we run our for loop. And all should be well. So boot, black, small, $45. 1, 2, 3, 4, 5, 6. There we go. So if this form at the top were properly formatted, protected with some kind of admin login, it would essentially be a means for a store manager or a non-developer client to add and potentially remove or edit inventory on their store page. And that is made possible by a constructor function. And you could do it without the constructor function, but it is a lot easier with that constructor function. This is a very small example also. In most cases, what constructor functions are really used for is for immediately converting huge swaths of data into usable JavaScript objects. JavaScript objects are critical for exchanging information between servers. Once we get into APIs, you'll realize that APIs are made possible by exchanging JSON documents. And JSON, JSON, stands for JavaScript Object Notation. All it does is really make a call to an external server that returns a gigantic JavaScript object. And constructor functions exist to turn data, which is often manually entered somewhere in a server into a JavaScript object that can be parsed in meaningful ways, just like this, where we use a very similar constructor function to create a dynamic e-commerce site. And you could extend it, obviously. There's no reason why why color isn't an image, and every single image argument could be a file path to an image unique to this boot. And then what you're doing is actually creating an e-commerce page with pictures. So here's Codify's example of a t-shirt store. Now this particular example does not use functions like this, which all relate to each other. These t-shirts are still manually entered using our initial approach, which is where we were pushing each new piece of inventory to our empty array. But what I showed you is just one more way of automating a part of that. And in addition to that, it's also a way of compartmentalizing big chunks of your code in functions which can call each other. That's another thing that you should start thinking about as you get deeper into JavaScript. You are going to want to make your code more referential, more compartmentalized, easy to separate, easy to maintain, and easy to continuously update. Because if this code was not all contained in functions, it would be harder to make changes to the logic. But instead, we know exactly where to look, where every function points. We know exactly what's happening at a given stage of the process. Okay, so I hope that was helpful. I know constructor functions they feel pretty opaque or esoteric, but they are extremely useful functions, extremely useful things to know. What I'm not going to do is run through the exercises for this week because they don't make a whole lot of sense. They don't really help you appreciate what constructor functions are for. However, they are good to run through on your own because they will get you writing constructor functions and seeing the difference between object literals and objects produced by constructor functions. The only thing I want to add to this is we can include in constructor functions methods, or essentially functions of their own. And an example of this might be this dot sales tax equals, and in here we would have a function which returns this dot price times whatever your sales tax is, 0.05 if it's 5%. And what's going to happen is sales tax will be dynamically generated each time. You don't need to feed sales tax in as an argument because it's dependent on one argument and another hard-coded number. So now every time you create an object, it's also going to have a sales tax property. And you can use this sales tax property in the next payment processing part of your payment processing page of your application. Okay, and it doesn't have to be sales tax. It could be any kind of usable stat. Last time it was updated. Number of times it's serviced per day. Average Yelp star rating. I don't know. Whatever it is you want. So anything can be dynamically calculated based on other arguments inside of a constructor function. So these can get very complicated, but also very useful. All right, let's move on. Week 12. I'm going to take a quick break for a couple minutes. So if anybody has any questions, now's a good time to ask them, and I'll be right back. right, 0 questions. Well, that's encouraging. Anyway, before I move on, actually, I did want to point out one more thing. I'm going to delete all of this code. Keep in mind, this is not the only way to do the e-commerce solution. There are even more efficient ways, or you don't have to be perfectly efficient about it. You just need to use constructor functions, get them under your belt. But something I want to point out here. So if we have this shoe constructor function, nothing else, we don't even need the inventory. I'm just going to create a new shoe variable that runs this constructor function and feeds in parameters. Boot, black, large, and okay, well, one thing here is price. In order to use this in this sales tax method, price needs to be a number. And you need to bear that in mind because the way I was writing it before with the $sign is a string, and if you try to multiply a string by a number, you're not going to get what you expect. So it needs to be a number if you want to run this function successfully. And if it's a number, you need to take that into account when you concatenate it into meaningful data displayed on your HTML. You might need to concatenate it with a $sign or with a .00 after it. You need to format your data. Anyway, I run this constructor function. Let's jump into my console. And now I can call new shoe. And I get the full object. And notice we've got name, boot, color, black, size, large, price 45, and sales tax. Let's see that little F? That means it's a function. So sales tax is a function. And now that I've created new shoe, I can access new shoe.name, boot, new shoe.color, etc. If I try to access new shoe.sales tax, I get a function. I don't get what the function returns. I get the function itself. So if you want to use the information that would be provided if sales tax actually ran, you need to actually run and invoke the function new shoe dot sales tax followed by opening and closing parentheses, and then I get 225. Okay, that's usable information. If you don't want to go through this process, if you don't want to have to remember this opening and closing parentheses, then you can force this function to invoke itself immediately as soon as the object is created. And this is something that we as a class have not dealt with yet at all. It's called an immediately invoking function. And what you do is you wrap the whole thing in parentheses and follow it by opening and closing parentheses. Immediately invoked function, or IIF. Immediately invoked. I think that's the acronym, IIF. Okay? Immediately invoked functions are really useful for situations like this. Okay? It's going to run the function right away, return immediately something that is relevant to it, and that's what's going to be stored in the sales tax property. Let's try it now. New shoe. Look at that. So, it's not a number. That's not right. Oh, I think I need to do Z for price. Yeah, there we go. Okay, so what I ran into there was, I don't know if you saw it, useful moment to point out an error you may run into is sales tax is being returned as NaN. If you're not familiar what NaN is, it means not a number. Not a number. It's returning not a number because it's trying to multiply something by a number, and if it cannot understand what this is as a number, it's going to return not a number. It's going to tell you, I can't do this. I can't do this because it's not a number. The result is not going to be a number. It's not what you want. That's what that error means. And the reason why is because when I wrapped this function in parentheses like this, when I turned it into an immediately invoked function, I changed the meaning of this within the boundaries of that function. Okay, without those parentheses, this refers to the same this that all of these do. But once those parentheses are wrapping the function, this now refers to itself, and it doesn't have any argument, it doesn't have any parameter. It's referring to something that doesn't have a meaning, is undefined, and as a result, it cannot multiply that by 0.05. So I had to come in here and change this.price, which we defined up here, but remember, this has changed its meaning once you arrive inside the contained function like this. So instead, I had to use the base argument that was fed into the parent function, z, and which was also given a value here. Z is now equal to this.price at a point in time when this is exactly what we want it to be. Okay, so once I changed it to z, we were able to use it appropriately, and it returns 225. And now that I have made the function immediately invoked, I can simply call sales tax, and it will give me what it returns, whereas previously I had to manually invoke the function. Okay, so immediately invoked function looks like this: function, your code, and then you invoke it. This is an anonymous function. It is only invoked by forcibly invoking it. Okay, so if it doesn't have a name, you can only invoke it like this, or by nesting it inside some other function that automatically invokes it, or by storing it in a variable name. In a variable name, Jesus. Okay, in a variable name, which you then invoke, just like any function. An anonymous function is as opposed to a function that has a name. Okay? So that's a little bit of function theory there for you guys to chew on. Immediately invoked function allows you to save a step in a situation like this. And the meaning of this can change dramatically on the fly. So if you're unsure of what this is, test it, console log it constantly. Because that's a very common scope problem that can cause issues. If I was really married to using the this.price nomenclature, which I'm not, then what I would honestly probably do is do something like var that equals this up here, and change all these this to that. So now that is guaranteed to mean the appropriate this, and then I use it as its own variable. It's complicated, and you probably don't need to worry about it too much just yet, but I do want you to be aware of all of these potential scope issues which can come up in JavaScript. There we go. Still works because of that. Okay. Moving on now, for real. Week 12. How would you display a random whole number between 1 and 20? Okay, well, by now you should know math.random, right? But what does math.random return? Let's try it. So I run math, capital A-M, because it's technically a constructor function. Math.random, I get something like that. Run it again. Run it a couple times. What do you notice about all of these? All of these are very, very small numbers. And that's because math.random doesn't generate random whole integers. It generates a random number between 0 and 1. Okay, so basically from 0.01 to 0.09, except it goes much, much smaller, obviously, because it can. Okay, it will only generate a random number between 0 and 1. So that's the first thing that you very much need to consider when dealing with math.random or generating random numbers. What we want to do is generate a random whole number between 1 and 20. Let's focus on the 1 and 20 part. If math.random only generates numbers between 0 and 1, how do we generate numbers between 1 and 20? Well, if conceivably the lowest number we could possibly generate is 0, what do we have to do to get that hard-coded minimum, 0, to be the minimum that we want, 1? Well, what's the difference between 0 and 1? It's 1. We need to add 1 to math.random to make sure that no matter what, we're never going to get a number lower than 1. Okay, that should be self-explanatory. That should make sense. You should be able to be okay with that at this point. The lowest possible number random can generate is 0, and we want the lowest number in our range to be 1. So we're going to add 1 to any number that we generate. Make sure that that we can't actually arrive at 1. We could do that, or we could always round up, but I'm going to go with adding 1. This is generally the safer way to go about it. Okay, so if we add 1 to every number, then now what is the greatest number that we can generate with math.random? It's 1. And what is the greatest number that we want in our range? It's 20. So what do we have to do to 1 to get it to 20? We have to multiply it by 20. Okay, disregard the plus 1 at this point. We just need to multiply it by 20. You don't want to try to multiply it by something to get it. You don't want to multiply it by 19. Although I guess you could. But what we're going to do is, in fact, multiply it by 20, because it is easier to remember. We're adding 1. We're multiplying it by the upper limit of our range. Between 1 and 20 is what we're going for. And then what does that give us? It gives us a lowest possible number of 1 and a highest possible number of 20. Is that correct? Let's check that. I'm confusing myself again. Nope. That is not correct. Right, because now that we're adding 1 to math.random, I'm doing this out of order, I apologize. We do want to multiply it by 20, but what we want to do is multiply it by 20 before we add 1. Okay, so to get our maximum number, we want to multiply everything by 20. And to avoid 0, we need to add 1. So now our lowest possible number is going to be 1, and our greatest possible number is going to be 20. 21. Our greatest possible number is going to be 21. Well, we want to avoid 21 too, so we're going to do something else. We're going to use math.floor at the outset, which is always going to round down to the nearest integer. So, because I've probably confused you, because I've confused myself, let's just start over. Math.random will generate a number between 0 and 1. It won't actually generate 0 or 1, but it will get really damn close. Okay? So, in theory, if we multiply every random number generated by 20 and add 1, we'll never arrive at 21. We might have 20.9999999, but we'll never reach 21. So how do we get 20.99999 to be 20? We use math.floor, which is automatically going to bring it down to the lowest, the next whole integer below it. It's going to cut off all the decimal points, essentially. So 20.999 will convert to 20. And that takes care of our max. Okay? And we add 1 because our min is going to go from 0.000001 to 1.000001. And with math.floor, that brings it down to 1. So that takes care of our minimum. All of this is to say, to generate a random whole number between 1 and 20 using JavaScript, you use math.floor of math.random times your maximum plus 1, or plus your minimum. Okay. I hope I didn't confuse you. I probably did. But it's your the equation is math.floor, and inside those parentheses you run math.random times your max plus your min. Okay, so if your minimum is 0, if you're going from 0 to 20, you don't need this at all. This is how. And I hope that helped explain why generating a random number looks way more complicated than it should, or what math.floor is doing in this scenario, or why we're adding 1 to the final calculation. Why would you want to select a random name from an array and display it? Well, if you ever wanted any kind of a shuffle feature in your Spotify playlist, in your photography album, in your, I don't know, your background color, any kind of shuffle feature is driven by a random number generator. Think if you had an image element whose source was dynamically determined by a random number generator, which generated a number that was plugged in as the index of an array containing a series of image file paths. Well, then every time you hit the button that would generate a new random number, a different source would populate that image element, and you'd have a new random image show up. It's just a shuffle feature. What is the built-in JavaScript method to find out the date and time? This part's all, this stuff is all pretty easy. We don't need to spend a whole lot of time on it, but var date equals new date with a capital D. And what does the capital D mean, and what does the new mean? It means it's a constructor function. So if I run that, and then I call date, we get the full date. We even get the time zone. Yeah, it gives us everything that we need, date and time. How would you display the current year in the console? Well, I could do new date dot get, is it get full year? Yeah, 2017. Get full year. If I run get year, it's going to do something different. It's going to tell me how many years it has been since the year 1900. So get full year, you will run into this again with other issues. There are other issues that we will run into when we try to parse date and time information, which we'll see when we get to the exercises. How would you display the current hour in the console after 2 seconds? Well, to do anything after 2 seconds, we need to use a setTimeout function. SetTimeout. And setTimeout functions take 2 arguments. First argument is the code that we want to run, and the second argument is the time that you want to wait to run the code. So if I put in 2000 in here, that means 2000 milliseconds or 2 seconds. So we're going to wait 2 seconds before we run whatever we put in here. And I'm going to write the function that is going to cause an alert to pop up. And the alert is going to contain the current hour is plus new date dot get hours. Okay, so inside the set timeout we have a function which causes an alert to pop up, and the whole function will run after 2 seconds have elapsed. Reload, and then we get our alert. The current hour is 15. Okay, now how can we get that hour to show up in a more, well, not in military fashion? We could, let's put a variable in here called current hour, and let's define the current hour variable up above. Sorry folks. Var current hour equals, well, we can use date because we already defined date as new date. Date dot get hours. And then we can have an if statement. If current hour is greater than 12, then current hour equals current hour minus 12. Okay? And we could also, I'll come back to it. So now reload, wait 2 seconds. Current hour is 3, which is true, it's 3:55. If we want to do AM PM, well, let's do an AM PM variable and set it by default equal to AM. And if current hour is greater than 12, then AM PM equals PM. Make this a string, sorry. And then we'll simply plug that in to our concatenation, current hour plus AM PM. Wait 2 seconds. Current hour is 3 p.m. Done. How would you display the current hour with a DOM event listener? Well, let's go ahead and put a button. ID equals button. Click me. The button does not have an on-click attribute. Okay, bear that in mind. I'm going to get rid of our set timeout function. And I'm going to do document dot query selector btn dot add event listener. Event it's going to be listening for is click, and when it does hear that click, we're going to run the following function. And the function can be the exact same as the one in our set timeout. An alert will pop up. Reload. There's no alert from our set timeout, but when I click on my button, I get the alert. Okay. Now, it doesn't matter that this is a button. I could get rid of this button entirely, and rather than targeting my button, I could have document.body.addEventListener click. And now, even though there's nothing to click on, when I click, oh, my body has no height, doesn't it? Yeah. My body has 0 height. So does my HTML. Let me give my body a little height. So even though we have nothing to click on, no button, as long as I click in my body, it will hear it and we'll see the alert. And that's the significance of DOM event listeners. Doesn't have to be click either. It could be scroll. So when I scroll on my body, I'm going to scroll. You're not going to see it, obviously, but I'm going to scroll. Oh, there's nowhere to scroll. Make it really tall. Oh, it's not working. Okay, well, I'm not quite clear on why that's not working right now, but there are obviously other event listeners. They're much easier to manipulate when you actually have content in your page. But now with double click, you get the same thing. I double click and the alert pops up. Click and the alert pops up. Other DOM event listeners are scroll, as I showed you, although it didn't work just now. Mouse enter, mouse leave. All kinds of things. And resize. So I could do document. That's how I should have done it. You can actually use the window rather than the body or an element as the element that the DOM will be listening to. And if you can actually create an event listener for resizing your window. So it would listen. When I resize my window, it will do something like change the size of an element or cause elements to disappear. It's just think of it as a more advanced form of a media query, although you can do other very cool things with resizing the window and relying on it, listening for it as an event listener. What are 3 ways we can add events in JavaScript? There is the attribute method with like an on-click attribute in our button, or an on-scroll attribute in our body, or anywhere else. There is an add event listener. Jesus. And in addition to event listener, there are DOM listeners. What is the event listener we should use for modern browsers? Add event listener. So the one we've been working with. Exercises. Create an array of 5 numbers, each with 2 decimal places. Var numArray equals 6.05. I don't know why I put quotes in there. 6.05, 4.99, 7.74, 1.20, 0.36. Loop through the array and round all numbers to the nearest whole integer. I'm going to do this in my console. We have a numArray. Try that again. There we go. We have numArray, and I'm going to write a for loop. For var I equals 0, I is less than numArray dot length I plus plus, and inside our for loop, we're going to console.log numArray, actually, console.log math.round numArray I. And we get 65810. So all the numbers in the array are rounded to the nearest whole integer. That's math.round. As opposed to math.floor, which automatically rounds all the way down, or math.ceiling, which rounds all the way up. Add each rounded number to a new array. Our new array equals empty array. For var I equals 0, I is less than numArray.length I plus plus. New array dot push math dot round numArray I, and then we will console.log new array. There we go. New array has all of the rounded numbers, all the rounded integers. Create a function that produces 10 random numbers between 1 and 100. add each number to an array of numbers. I'm going to leave new array because we're going to use that empty array. Get rid of everything else. And let's start with just the math.random function. Okay, so we know we need math.random. And what is going to be our maximum number? It's going to be 100. So let's add 100 to our math.random number. And we want to go from multiply 100. Between 1 and 100, so we need to add 1 to account for that possibility of encountering 0. And to make sure they're all integers, we're going to do math.floor. Or actually, let's mix it up. I'm not going to do the add 1 part. We're just going to do math.ceiling. And we want to generate 10 random numbers, so we're going to use a for loop. Our I equals 0, I is less than 10, I plus plus, and inside of our for loop, we're going to push these random numbers to new array. And then we're going to console.log new array. Well, that's just not right. Or did I spell it wrong? Math.ceil. Oops. Here we go. And we have 83, 53, 63, 41, 16, 36, 73, 49, 98, 60. Okay, so there we go. Write out a function that creates a few variables that stores the following information: the whole date, the current hour, the current minute, and the current second. So function generate date. Okay, so we're going to do let date equal new date. And for where we want the whole date, so full date equals date. For current hour equals date dot get hours. The current minute, date dot get minutes. And current second, date dot get seconds. And then let's run generate date. Console.log full date, current hour, current minute, current second. Okay, so there we get the full date. Current hour is 16, 4 o'clock now. Current minute 8, and current second 2. Inside the function, create a variable that will display the current time in HHMMSS format. For HHMMSS equals current hour, we'll come back to that, plus, we're going to concatenate a colon, plus current second, we'll come back to that too, plus, I skipped a minute. console.logging all that. We'll just console.log HHMMSS. And there we go. What we need to do now is make sure that minutes and seconds are 2 digits long, even if they're not. But I will come back to that. What's next? Create a few more variables to store the current month, day, and year. So we've got var current day equals date dot get day, var current month equals date dot get month. We're going to need to watch out for that one. We'll see. Var current year equals date dot get full year. Not going to console log them, but inside the function, create a variable that will display the current date in the ddmmyy format. Var ddmmyy equals current day plus current day plus concatenated forward slash plus current month plus concatenated forward slash plus current year. And after this, console.log them both. And what do we get? Something that is not right, right? Well, it is actually, but it's a matter of how the computer actually interprets the information here. And what it comes down to is actually that when calculating a month, the computer uses indexes, just like in any array, which is to say that the item at the 11th index of the month array is actually the 12th item in the array. So 11 is December, 10 is November, 0 is January. Make sense? So what we need to do to current month is we need to get month and we need to add 1. And that will make it more readable by a human. Okay, and we want full year. We don't want the 4-digit year. So there's a lot of ways we can handle that. The easiest way, in my opinion, is simply subtract 2000 from the get full year, and it will be relevant for at least another 83 years as a piece of functional logic. So then the only other issue is the get day and the minutes and seconds. We need to ensure, actually everything, we need to ensure that they are that they stay at 2 digits, even if they're not. So this 1 needs to be 0, 1. So we can actually make a whole separate function for that. I'm going to do that. We're going to do function. Let's just call it 2 digits. And it's going to take a number. And what it's going to do is check if number is less than 10, then number equals sorry, 0 plus number. And what that's going to do is concatenate the actual digit that is number plus a string 0. Make sense? Now this is going to get dicey when you try to make your clock applications, but not my job to figure that out for you. I need to leave at least some mystery for you guys to try to solve on your own. But this is a really simple solution to displaying a 2-digit second, minute, date, hour, whatever you need. So now that we've set up this function, I'm going to actually plug this, I'm going to invoke this function every time I run this. So where is it a potential problem? It's a potential problem in current hour and current minute and current second. Is it a potential problem in current day? Yes. Current month? Yeah, it is, although we're not dealing with it yet. And then current year? No, because current year is always going to be 2 digits. Although still, why not? Let's just do it for good measure. Make sure our logic is consistent. So now, let's go ahead and see what we return in the console. Crap. That's not right. Let me see something. Let me try and test this out. 2 digits on 4. Console log anything. Okay, so the 2 digits function is working, so that's not where the issue is. Oh, because it's not, I'm sorry, I'm being stupid. It's not returning anything. So if number is less than 10, I actually want it to return 0 plus number, not to change the value of number. I want it to return 0 plus number. So if you plug in 4, it will return 0, 4, and that is what will be stored in the given variable up here. So with that, still not working. Let's try this. 2 digits, new date dot get hours. Because there's no else. God, I'm killing it today. Else return number. So if number is less than 10, it adds 0 to it. Otherwise, it's just going to return the number as is. And we are good to go. Thank God. Sorry, folks. I am tired today. But that takes care of that. We already saw how to resolve the military time issue. If you're interested in resolving that on your own, go for it. That just about rounds out week 12. Write some code that will run this date time function every second. Okay, fair enough. So we're essentially making a clock. Generate date is what runs this code, and console.logs the date and time. So 2 different ways we can do that. One is the set timeout method. And we're going to call generate date. You don't need the parentheses there because the set timeout function actually takes care of invoking it for us. And we're going to do it after 1,000 seconds. This will cause generate date to run after 1 second or 1,000 milliseconds, but it's not going to run it every second. So what we can do here is we can actually put this set timeout function, which calls generate date after 1 second, inside of generate date. And then we simply call generate date the first time as normal. So now generate date is going to repeatedly call itself every 1 second. That'll work for us. Let's see. There we go. And see, the seconds are increasing. So we've effectively made a clock now. That is one way of doing it, using the set timeout and causing the function to call itself. Another way is to use the set interval function, which is very similar to set timeout, except rather than asking it to wait 1 second before running invoking generate date, it now will invoke generate date every 1 second. So if I refresh, 1, 2, 3, 4, does the same thing. Okay, so set timeout versus set interval. If you use set timeout, you need to put that set timeout function inside the function itself, so it calls itself. It invokes itself. All right, and that's our clock. To actually make it a clock application, you need to take everything we're console logging and populate it meaningfully into your HTML, which you are all capable of doing by now. So I'm not really going to get into that. The countdown example is a fun one. You can, the only thing I'm going to say in relation to the countdown example is you can complicate your date constructor function. You don't need to just run new date. You can feed an argument in here and actually generate a date for a specific point in time. I'm not going to tell you how, but you can do that. And if you can do that, then obviously you can generate a date for now, for the current time, and a date for 3 hours from now, and figure out how many seconds are between one and the other, and you have a countdown. Or you can generate a date for now and a date for next April, and figure out how many days are between one date object and the other date object, and there you have a bigger countdown example. Okay, so that's something to look into for making this project more complicated or compelling. And obviously you can make your clock look awesome. One of my students did in fact do that. He made an incredible looking clock. All right, moving on, week 13. Last one for the day. How would you change a string to all lowercase letters? For string equals Evan Winston. String, you have capital letters, string dot to lowercase. It's all lowercase letters. Why is to lowercase method useful? Well, we already saw it in our Zodiac app. It allows us to prevent all of our inputs from being case sensitive. And if they're case sensitive, they're potentially more punishing for users. I mean, nobody wants to. It's not really asking a whole lot, but for something like a Zodiac, or if you're and imagine if Google search was case sensitive. It would completely change how we use Google. It's not mind-blowingly life-altering, but it is an important distinction and an important feature when it comes to user experience that you often need to account for. To lowercase allows you to force user input into lowercases before you try to match it against some of your own data. It lets you compare apples to apples and oranges to oranges. Why is the trim method useful? Well, what does the trim method do? Let's say I have a bunch of spaces, superfluous spaces, wrapping around my name in the string variable. So if I call string, I see all those spaces, but if I use string.trim, it actually eliminates those extra spaces, which is really useful. Because if I look at string, and I want to know how many letters are in there, including that space in between. Well, string.length tells me 22, but string.trim.length tells me 12, which is much more accurate. because that's how many letters or characters are in my name, including the space in the middle. While we're here, how would I get the length, how many characters are in this without that space in the middle? I mean, I could subtract 1, obviously, but to do it right, let's do string.trim, which should give me Evan Winston. Trim. This is something else we're going to learn in this week's material. Dot split along that space. Dot join. Dot length. This is a fun one. Here we go, 11. Perfect. I'll explain exactly what we did there in a little bit. When could you use the trim method? Well, anytime you need to pull the first letter of a user input and you want to be sure it's not a random space that accidentally got put in there. Or anytime you need to find out how many characters are in a string. You use the trim to make sure that there are no extra superfluous spaces before or especially after. A lot of people will type a space after they type something into a search bar or an input bar. What is the difference between split and join? The difference should be pretty obvious. Split splits a string, and join joins strings together. So let's break this down, what we did before. String is this. String.trim is this. Okay, so string.trim, what we're dealing with is Evan Winston. That's what it returns without the extra spaces. When we do string.trim.split, let's do it without the space argument inside. We just do string.trim.split. What we get is an array that contains a single item, Evan Winston. Okay, so it didn't do much for us except put our string inside an array. But if we do string.trim.split and we feed it, let's first feed it no characters, just these, no, forget it. I'm going to put a space in there, okay? You put a space as the argument inside of split. What it's going to do is split this string anywhere that it sees a space. When it sees a space, it's going to just cut it. And it's going to return an array of 2 items now. It has returned an array of 2 items which are separated by, hi Matt, I'll address your query selector question in a couple minutes. Sorry, I just saw it. So dot split, you give it an argument and it uses that argument to determine where and when to split a string into individual items of an array. So it saw the space between Evan and Winston and said, everything before this space is going to be 1 item, everything after this space is going to be another item. Okay? If I do the exact same thing but with no space, but with quotes in there, then I get the entire string broken up into an array of individual characters, which is useless in most cases. It's still important to understand though. Okay, so that's split in a nutshell. Join actually allows you to join strings together or join different elements in an array. So remember, split with a space inside returns an array of 2 items. And I can then use .join to join everything inside together. If I just do that, .join, no argument, I get Evan, Winston. That's important. Okay, if you give join no arguments, it will join all the strings or all the items in the array with a comma. If I put an empty quotation mark in there, then it will just join them together like it's concatenating. Okay, if I try to join them with a space in there, it will insert a space between all the strings. Or I could get as crazy as I want. I could even put a a whole new string inside .join, and it will insert it in between my strings when it joins them. Okay, so that's the difference between split and join. You can often use them together like this to reconfigure data or reconfigure strings to be more useful to you for use in your website or application. Okay. Now, Matt, you asked how do you know when to use Query Selector? The answer is you can use Query Selector anytime. The important thing is knowing what it returns. So I'm going to jump into the console here. The obvious thing to think about is, like, if an element has an ID and you want to select it in JavaScript, you should inherently think of get element by ID. It's the easiest and most direct way to target an element. Okay, but if an element doesn't have an ID, that's when you need to start thinking, well, do I need to use get element by class name or get element by tag name? And if I do, how am I going to make sure I'm grabbing the right index of the collection of HTML elements that those commands will return? So that's where it takes a little more thinking or logic to make sure you're grabbing the right element. Query Selector is simply an easier way to target a single element. Query Selector is a newer command. So it's actually meant to replace get element by ID, and to a degree get elements by class name and tag name. So if I have, let's see what we have on this page. There's an H1 here with a class of section header. H1 here with a class of section header. So I can use document.query selector H1 in quotes H1.section header. And what that's going to do is it's going to return that specific HTML element. It's going to return the first one that it finds which matches this selector. Okay, so for classes, that's important to understand. You're not going to get all the section headers on this page. You're just going to get the first one. If you want all of them, then you need to use Query Selector All. And now we have 3 H1s with the class of section header. Okay, so Query Selector and Query Selector All together are just newer commands that were intended to replace get element by ID, get element by class name, get elements by class name, and get elements by tag name. You should still know how to use both, and most importantly, you should understand the difference between what these return. Even if we only had one H1 with a class of section header, if we used Query Selector All to target it, we would still return what's called a node list, or collection of elements. It's like an array. It would only have one item, but it would still return an array. So if you wanted to target that one item, you would need to use an index at the end of that whole command. Okay? So the logic is no different, except that it does accept CSS selector syntax. The dots, the hashtags, you can't use that in get element by ID, get elements by class name, etc. But you do use them in Query Selector and Query Selector All. What is one use of regular expressions in JavaScript? You know, I would like to get really into regular expressions, but it's probably going to have to wait until next time. So bear with me for now. I'm going to skip over the regular expression portion of week 13, and we'll get into it next time because it's already 4:30. Create an array of 5 strings. Make sure to capitalize some of the letters in your strings. I'm just going to do an array of names. Okay. Loop through the array and change each string to lowercase and add them to a new array. Or new array, empty array. For loop, for I equals 0, I is less than my array dot length, I plus plus. new array dot push my array I dot to lowercase, and console dot log new array. Reload, open my console. Evan, Lisa, Adam, Matt. Okay, all lowercase. Loop through the new array and log the first and last character of each string to the console. This is a good one. This is a nice little brain teaser. We're going to do another for loop for m equals 0. I don't actually have to change the letter here for reasons that I'm not going to explain right now, but it's always a good practice to use a different character for your iterator in a different for loop if you're dealing with multiple for loops on one page. It's much easier on yourself, on anyone else who ever needs to look at your code, and it can help you avoid problems in certain cases. So var m equals 0, m is less than new array dot length, m plus plus. And what are we doing here? We're logging the first and last character of each string. Well, how do we log the first character? How do we access the first character of a string? New array m is going to be the string itself, and new array at the index of m at the index of 0 is going to return the first letter of each string in new array. E-L-A-M for Evan, Lisa, Adam, Matt. Okay. Now how do we do the last one? Well, we can't do 0 again. This is where it gets complicated. It's the same pattern that we've discussed before, though. It's going to be new array at the m index dot length minus 1. So we get E and N, L and A and M, M and T. Okay. So new array at the m index is the string itself dot length minus 1. Don't let the number of iterators fool you. Create a variable and store your name in it, and using the split method and a loop, log each letter of your name to the console. Var name equals Evan. For var I equals 0, I is less than name dot length, I plus plus. So I could just console log name at the given I index, and that will loop through every letter in that string. But it wants me to use the split method and a loop. So first, I want to take var array, it's an empty array. I'm going to push to the array variable my name dot split, and I'm going to feed it these two empty quotation marks so that it splits it between each letter. And we can test this by console logging array before we jump into the loop. Okay, so the array has split my name into 4 letters. That's what we got. And now I can change name here to array.length and array I. And that should satisfy the question's logic. Yep. Okay, so using the join method, put your name back together and replace all occurrences of one letter with another. I'm going to make my name with my full name. Okay, and I'm going to replace all n's with x's in my name. I'm not going to do a for loop, don't need to do that now, but we've got array, which should split my name up into characters. So what I'm going to do is take array, and I'm going to join it I'm not going to take array. I'm just going to take name, which is my full name, as a string, and I'm going to split it wherever I see an n. I'll split it wherever I see an n. So let's actually see what that is. Let's try and plug that into the console. That returns an reload. So that returns an array where wherever there's an n, it has been replaced by this comma or turned into an empty string. So once I split it, I'm going to join it with an x. Let's go ahead and see what that returns. And there, we have successfully replaced every n in my name with an x. We split along the ends and we rejoin it with x's. Also a very useful thing to do. So let's say we have a string that is some kind of sentence. I think corgis are the best dogs. And document.write new string. So now my web page says, I think corgis are the best dogs, but I want to take new string and I want to split it where I see corgis, and I want to replace it with beagles. And then I want to just plug that into document.write. Or better yet, document.body.inner.html equals new string.split, take out corgis, rejoin it with beagles, hit enter, and it rewrites it to be a much more truthful statement. Okay? And then the rest of these exercises are for regular expressions, and regular expressions are huge. They're so valuable, but a lot of students gloss over it because they are difficult to teach and they look incredibly intimidating. So it's completely understandable, but I would like to spend some real time on regular expressions, so I will save that for next time. We'll start with regular expressions, and then we'll talk about APIs, and I'll start introducing Vue.js, which for me is how I'm choosing to cap the end of my courses. I spend 2 to 3 weeks on Vue.js and teaching my students what should be the next intuitive step after graduating from Codify. You all need to continue learning and commit to continuing to learn after you graduate, and in my opinion, the next step for all of you should be focusing on a popular front-end framework, of which React.js is the most popular. Vue.js is up and coming, and it's actually much easier to jump into. And personally, I think it might actually replace React.js very soon. And then third on that list is going to be Angular, which is much bigger, much more difficult to get into, especially now that they're in version 5. And it's just a much more complicated structure, but it's also much bigger. Anyway, I'll talk more about those next time. Thank you all for coming. I hope this was helpful, and I'll see you next week. Yeah, have a happy holiday if I have not already said that. I won't see you next week because next week is Christmas. So I'm not going to be holding a review session next Monday. I will see you in January. Goodbye, everybody.